I wanted to take a minute today at the beginning of the podcast and say thank you to our sponsor, Huber Engineered Woods. Huber has actually been a sponsor of the podcast since 2020 when we decided to start this little endeavor. Without our sponsors, this content is probably not something that happens. But I think the best part about having Huber as a partner on this is it's an incredibly authentic alignment. Peter, Steve, and I all use Huber Woods. I've been using Advantech Subfloor for coming on probably 21 years now. I've been using Zip System and Zip System with the insulation on the back, the Zip R, since 2013. It's a system that I believe in. That systems approach where things play well together. They have design parameters that allow you to use their system for what you're working on. It works. Their tech support's there. Their knowledge is there. I've never had an issue with their product, and it's a great thing that they've decided to sponsor the podcast. So thank you, Huber Engineered Woods.
I'm Jake Bruton, and welcome back to the Unbuild It podcast. Today I have with me Steve Basic and Peter Yost.
Yo.
These
Hello.
are the normal, regular, everyday, average podcast hosts that are with me on the Unbuild It podcast.
Average.
Yes.
I'm going to have to bring it down a notch if I'm going to be average.
A little excited.
Everyday average.
Today. And today we have the start of what will more than likely be a 4-part series.
Sure.
You'll see why I'm going to say 4-part series here in just a second. Steve, you got to quit squeaking your mic. You're going to drive me bonkers.
I have the squeaky mic.
Yes, you do have the squeaky mic today.
I have the happy feet pad.
We're going to have to take it away from him. It's babysitting here already. We're going to...
You got nerve saying you're babysitting us. Like, wow.
We're gonna have a conversation. The basics of building science, right?
Yeah.
We're gonna take it back. We're gonna talk about what should be everyone's starting point for understanding when it comes to building science. And we put the word science on there, but it really doesn't matter. This is what you need to understand if you're going to construct a building, right? If you're going to create a successful indoor controlled environment that is built to last, you have to understand what the risk is for these 4 things, to be able to create control layers for these 4 things, and be able to manage your risk appropriately for your environment. Is that fair to say? We're going to talk about the 4 control layers today.
We're going to talk about one of the 4.
Yes.
We chose the word control to describe the layer. And it used to be we called them barriers, and that was inappropriate.
Why?
Because we can't stop anything. We can just slow it down. And actually, control layers, some people call them continuous management layers because we're not really trying to control the water. We're trying to manage it. But
what's the difference between control and manage? Not to be pedantic.
I would say manage is more, it could be coaxing and encouraging rather than requiring, whereas a control layer implies the same thing as a barrier, which is I've got total control of this.
Peter has a different management style than I do, I guess. That's all it is.
Could be. I got better things to do with a few minutes than to decide whether I should use control or management.
Yeah.
This from a guy
Steve's
who
not gonna
really
say
thinks
please.
hard about terminology. That's surprising.
I do, but I think hard and then I hit it and I'm done.
Yeah.
I don't linger.
We're going to break this into 4 parts because in our discussions, there's always 4 of those control layers, those 4 management layers that we would talk about. Those 4 being water, air, and then the other 2 in whichever order you want to say them, vapor and thermal and vapor.
Right.
So
why is water first?
Why is water first?
Number 1 killer buildings.
I was going to say, I'd like to steal your phrase, but I want to...
No, it's not mine. I got it somewhere, I'm sure.
Yeah. $13 billion in insurance claims annually in the United States.
And we still think we can beat it.
Yeah.
That's the crazy part.
Yeah.
There's people out there, we really don't need to flash that window. We don't need to put that kick out flashing.
And
It's baffling.
Is it all about water coming down or mostly about water coming down?
I would say it's a lot of or a large percentage of water coming down.
And we rely upon gravity quite a bit, but we can't always count on it if we're building on the
We can
coast
count
or
on to
something.
wreck things too.
Yeah.
If you don't pay attention to it.
Yeah.
The most baffling to me is when I see somebody, the classic example is like a porch comes into a front elevation, say 3 feet in from the corner. And that whole corner is all rotted because the water comes off the porch roof and just rots it.
Mm-hmm.
And you watch the people over time, they take off the siding, they take off the building paper, they replace all the plywood, they put up new building paper, new siding, and they're done. Like they don't even think for a second of, why did this happen here and not over here? Like there's a reason why the wall rotted out right here.
Why would you get a different result if you do it exactly the same way? I have to admit, when I was doing remodeling full time with my brothers, we routinely went around and replaced stuff and didn't think, hey, I wonder if we could kick that load out. We could save coming back here. I mean, it wasn't our business model, but we should have been.
One of my favorite things to do now is
you just missed that.
What?
Their business model was continually to go back and repair things again and again and again.
He's the milkman.
Yes.
The Yosts are milkmen.
And I'm sorry that I'm the guiltiest person here. I can't argue with that.
I lost my
Raised Lutheran.
One of my favorite things to do these days is we do a lot of teardowns just because there's not available land. And to go into the tear down house like the day or week before, we're going to tear it down with a hammer and crowbar.
Yeah.
And open up around windows. Because the last one we did, I was like, okay, we're definitely going to find water here. And we didn't. And there was a couple places I found water that I wouldn't have suspected it. And then it's like you tear things apart further and further. And it's like, okay, that makes sense on why this happened. But man, I would have never guessed this.
When I was doing a lot of remodeling, we never took pictures of anything as we took it apart. And I'm constantly telling folks, like, if I can't be at the site, you've got to take pictures layer by layer because it tells a story.
Yeah.
Yeah. Yeah.
It's probably our best educator is taking an old building apart, especially one that's failed miserably.
So water is one that, virtually every building is going to see water in some way at some point, right? There's probably no building on Earth that's not going to get wet at some point.
I wonder if they get rained on.
The Nile used to be a fertile valley.
That's right. And they have their rainy season, I think.
So,
okay.
They didn't build the pyramid upside down, so that would have sheltered the tip.
That would have been very waterproof.
Yeah.
But it wouldn't have been able to concentrate the energy for the aliens.
Oh, yeah, there is that.
Sorry.
This is a lot of, that took a weird turn.
I thought we were going.
Yeah. Okay. And so that first method that you talked about was rain from above, gravity, water from above. And when we start having building science conversations, we sometimes have a tendency to just kind of breeze past the fact that the roof is one of our largest control layers. It's an enormous amount of square footage.
Mm-hmm.
It's installed almost exclusively by a subcontractor. Like, I don't know very many builders who still do their own roofing. And there's so many of the other aspects of control layers that we as builders end up tackling ourselves because they're important, because we're worried about them. But yet we're talking about the most important control layer, water. And I'm bringing up, which is probably the largest part of that control layer, the roof. And it's almost always executed by a subcontractor who is a lot of times not the most well trained subcontractor on the project.
They're probably
either.
the one with the least, like if you went with their crews, they're probably the least knowledgeable of the trade at the time they're doing it.
They have the least amount of on-the-job training almost.
Yes.
Yeah.
Yeah, I'm finding that changing a little bit. The last couple of jobs I've worked on, the roofing contractors have been above average in terms of understanding how water travels. And I think maybe it's in part because one of the projects was a low slope roof. And so the roofing contractor was a commercial roofer. And I think that the pressure is really on them to understand how water works on roofs because there's just so much exposure for them if they don't get it right. So I'm finding that roofers maybe are better understanding how to use water and control it with a layer.
I mean, what if we backed up a second? Because before you even get to the roofers, there's the design of the roof.
Yeah.
Right.
Yeah.
You know, remember Joe has his like crumpled paper routine when he talks about, he'll crumple up a piece of paper and he'll say, okay, like now waterproof this roof. And it's a, you know, it's got valleys and hips. It's kind of, but we see it all the time. And I don't know if you remember, I used to show a couple pictures of a house that we investigated north of where I live. And it had, I would guess it probably had about 200 feet of roof of wall, and the roof drained to about like 20 or 30 feet of it.
Mm-hmm.
Because it just kept getting pushed over here, and then this dormer kicked it over there, and then this L kicked it back. And it's like by the time it came down, it's like your gutter budget was, $50 for this house.
Yeah.
But yet the roof was like 25 square or something. It was crazy.
It was as if they were trying to create a waterfall.
Yeah. Like, can we push this water any more laterally on the roof before we let it come off? And I don't know. It's I try and be simple, and I know sometimes I get dinged for it, and that's okay. But
heck with that.
Well, the two people I'm trying to satisfy are the clients, right? And if they like the simple roof and they realize, I don't want any maintenance. I don't want dormers up there. I don't want to have that cheek wall rotting out. Just give me a nice, simple roof.
Don't draw me a problem that I have to try to solve.
Yeah, especially, a lot of our clients, it's literally going to be their last house. They don't want headaches. They don't care, like, who likes it or who doesn't. It's as long as they're happy and it does what they want it to do.
I recently showed you a set of plans, and for the roof plan, just very geometrically complex. And I don't know exactly what the impact the architect thought this was creating, but one of the responses was, well, it's not really all that complicated because it's going to be trussed. In other words, if I give a roof plan to a truss manufacturer, they can figure it out and essentially make it easy to frame, right? So it was like, I can do whatever I want with the design of the roof.
But that still doesn't solve the water issue.
Yeah. They were only looking at
They
were looking at it from the framing standpoint that, it's really complicated, but not for a truss manufacturer.
My favorite is, and you and I have talked about this before, the first thing that I do when I get a set of plans for review is I go to that roof plan and go, where's the water going to go? Like, what happens when this house gets rained on? I got a set of plans from an architect for a decent size addition and renovation. And I went to that page and I spent like 30 minutes staring at it. And I was like, this triangle that's in the middle of the roof doesn't make any sense.
Was it like a little cheek thing that just gathered water?
And I was like, it goes somewhere.
Yeah.
And I can't find it in any of the elevations, and I can't figure out where. And I finally called the architect, and he said, we're going to have to figure that out on site.
Yo.
And I thought, he can't make it work in the model.
Wow.
But I'm supposed to make it work in the real world.
So as a side note, I would take that personally. Like, I would never, ever, ever tell somebody we're going to figure that out on site because I don't know. Sometimes we'll say, okay, we'll figure out like the window casing on site, something like that.
We don't have to get
but not
the roof framing.
Yeah.
We'll figure that out on site. That's not the time, because how do you know what to order?
Yeah.
Like what length 2x or trusses?
Yeah.
Like, baffling.
Also, that architect has been in the business long enough. Do you not know that builders like to point out when you're wrong as an architect? Like, most builders get a kick out of that. You put this set of plans out to bid. I'm going to tell the client that this is a crappy set of plans and that we can't build that. Like, you're going to get thrown under the bus because I'm not going to be responsible for the fact that your roof has a cup built into the
Either
building.
that, or you just in your budget under framing, you say, unknown, and you just put 30K there. When the homeowner says, what's that 30K? It's like, well, the architect has this area. He says, we're going to figure it out on site. So I just put a line item in to carry that until we figure it out.
I don't know. And neither does your architect that you already paid for.
Definitely.
So don't draw a problem that is going to be a water management nightmare to start out with on any part of the building. We were talking mainly about roofs already, but the roof is the reason I brought up roof, not just because of the size and scale and the complexity and the things like that. I think it's the easiest example of what everything else on the building should do. Yes. From a water management standpoint. It should get rid of the water. It should get it away from the building, and it should make it so that it doesn't get held in tension.
Steve, if you have a 2-story gable, and that means that on that gable, the windows on the first floor are going to see all the water from it peak. So in the olden days, they quite often did like a little skirt that connected the 2 corners of the gable.
Eyebrow.
Yeah, an eyebrow. Yeah. And that broke up that plane.
It's called a Dutch hip.
Yeah. That's called a Dutch hip.
Yeah.
So
isn't it only a Dutch hip if the gable steps back, though?
Well, the gable, Well, no, because you could do. I mean,
it's a shed roof.
Yeah, it could be a little,
whatever.
But it looks like a Dutch hip.
Yeah.
Whether you move it back or not, it's easier to move it back because it's a little complicated. It's a 24-inch overhang. There's a lot of moment in those trusses just hanging off the wall.
But I always thought of the ease of the most exposed because that's where all the water comes down. But it's actually 2-story gables that wall, if it faces the wind-driven rain, that's a lot of water dumping on a vertical surface.
Yeah.
And it's a nice detail to break up the plane of the gable. In Brattleboro, there were tons of houses that had that detail to break up that plane.
Yeah, it was
you guys are so lucky to live on the East Coast where buildings have some sort of reference to history rather than just that.
I mean, we could drive. I could take you to a bunch of houses where like the second floor flares out and there's like a nice crown molding ribbon around that does it. I've also seen like on the first floor and those windows. There's a house just up in my neighborhood that's shingles and they built a little hood and it comes out like 2 inches.
Yeah.
And it kind of
at the head of the window.
You've actually driven me past that, and I have pictures of it on my phone.
Yeah,
it's a gorgeous little detail.
Really cool. So little things like that.
Those are both more aesthetically pleasing, and they shed water better. I wonder which came first, because a lot of the details of really older homes, they didn't have complicated polymers to seal things, and so they almost always used
chicken or the
design.
Egg.
I think on the little individuals, those are definitely water because you're not doing that to make that look pretty. You're doing that to kick water off the window.
Yeah.
But the roofy kind of thing that you're speaking of, that could be an aesthetic thing that, by the way, it's going to help us with water management.
So design can help us out a whole lot and make it easier. And then the water can come splashing back if you don't control it off the eaves. So there's just a lot of easy opportunities to make the entire building see less water.
Yeah. You were with it. I think it was Nathan, though. We were baffled. We did this one project. It was up in Manchester by the sea, and it was a brick building that was just very beautiful. It had all of the little jut outs and stuff that you would sit there as a lecturer and say, oh, well, they put that in the drip water. And we had the big lift and we were hosing this thing down and the water followed the contour of the wall. We were both amazed, like, that's not supposed to happen. Like, it literally was a film on every surface and just traced around. It was pretty incredible. It's the only time I've ever seen that happen.
I'm pretty sure it's because of volume.
I don't know what it was. It could have, I don't know if it was the brick. The brick was like a really like water struck, very slick brick. That I don't know, maybe it like bit the water a little better, or I don't know. But I was baffled, and Nathan was baffled too, because we just sat there and say, but it's not supposed to do that. It's not supposed
Nathan's
to
not
do
even
that.
here to defend himself. Sorry,
Nathan being my brother.
Nathan, your brother,
and you were at that building because it had serious moisture problems.
Bunch of problems.
Yeah.
The other thing
hold on real quick. What does the term water struck meant?
I think it's it's like
smooth face.
Yeah, it's a very ultra smooth face on the brick, so that they hit it with water. It's almost like if you've ever seen a plasterer work to get a really fine finish, they'll sprinkle water on it and then hit it again. So it's
I hadn't heard that
water
term before.
Yeah,
I thought I'd ask.
And but talking about going back to learning from buildings, if you go and look at like large masonry buildings after a rain event and see like the corners are more wet than the field of the wall, it tells you a lot about how water is moving around buildings. It just doesn't rain on the building and it's this uniform happening. And a lot of people don't quite understand it. And I see a lot of people on social media, like they put up that we're tearing down this building. And I was like, hey, did you do any, walking around or stuff? And they're like, no, we're just tearing it down. I'm like, man, what a missed opportunity to learn from how did they do things? How was that stair put together?
I have gone out to projects when I know there's a big intense rain coming, particularly wind driven, just so I can video and show the homeowners, this is why you have water here. But there's a project that I've been working on for quite a while up in Alstead, New Hampshire. There's a library there built in like 1910 by a very famous architect. And it's a cut stone granite building, and they have leaks, and they don't have institutional memory that stretches back to 1910. So there have been some changes made to the building, but I've told them many, many times, we could solve a lot if somebody would simply be on site, and particularly on that roof when there's a real big rainstorm coming. And it's about 2 hours for me to get there. And I said, if you want, I'll do that, but that's how we're going to find out. If we get intense water, does it roll over the face and go down? This is particularly on the north side. Is that what's causing this problem? Because I think it is. It's overwhelming the inset gutters that are, not at the eave, they're back. And the capacity of the storm is just rolling that water right over the edge of the building.
So I have a kind of an embarrassing, it's probably more embarrassing for my wife than for me story. We were in,
and this is a safe space, right?
I'd like to go on record by saying you probably shouldn't.
No. This is because this is about me being stupid. Not and
okay. All right.
Like it ended with her saying, "You're not allowed to walk with me the rest of the afternoon." But anyways, we're in Italy, Milan, in the main plaza there with the cathedral, and it has what are the things? Gargoyles, right? It starts downpouring. And I was like, oh my God, look at the gargoyles are working. So I am standing out in this plaza. I am the only person. Everybody else is huddled around colonnades. And I'm in the pouring rain shooting video of the water coming out of the gargoyle. Thinking like, and I come back, I'm like, this is the coolest thing. Like, how many people actually have video of the gargoyle working in the rain? She's like, you can't walk with me anymore.
It's a gutter. You just got excited about a gutter.
But it was really cool. It was thrown at like probably a 30 feet away from the building.
No kidding.
Yes. It was pretty wild watching it. And there were a bunch. It was like this water spout event.
Well, and in those days when they didn't have polymers to seal things up, they had to rely upon design.
The stone buildings with built-in assemblies like that and everything. My oldest was thinking about going to Virginia Tech. And so when we visited Virginia Tech, we sat in on one of Christine Williamson's lectures, and she was talking about something very similar, very adjacent. And there was a conversation about efflorescence on buildings that are getting wet. And we left her lecture and walked around the corner, and one of the newer buildings on campus, you could see a horizontal line up towards the top of the building where the parapet wall started. And we stood there and had like a 25-minute conversation about what was probably going on there. And then we turned the corner, and there were two more buildings that had the exact same stone that looked the same age, like they were less than 15 years old, that had that same parapet line on them. And he was just like, oh, that's terrifying that they built municipal, like,
buildings all
these
the same way.
Really expensive buildings. And I was like, yeah, guess how much it's going to cost.
Well, you have the building in Columbia we've driven by, and you said like the efflorescence, and then they clean it off.
They clean it off 3 or 4 times a year.
And then it just reappears.
Yeah.
And it's like, yeah. So it's water.
And you're talking about brick with mortar, correct?
Yeah, this was actually stone with mortar.
Oh, stone with mortar. Yeah,
it might have been concrete stone. You know, it. I don't know if it's real stone.
Yeah,
it may be fake.
But and I don't think it's really like that hard. We sit here and we joke about it, but in reality, you can look at it. If you're an architect, you look at the roof plan or builder and say, where will the water go?
Mm-hmm.
Right? Like, just drop your pen on a piece of paper and said, okay, if that's a raindrop, where does it go? Move down the roof plan 10 feet. Put another point. Where does that water go?
It's like a pen test, right?
Yeah. It's like, where does it go?
And then as soon as it's built, before you start covering things up, you have the ability to watch it happen almost always.
Yeah. If you're
I don't remember the last time we built something that didn't get rained on while it was being built.
Mm-hmm.
So
or that we couldn't spray with a hose.
Right.
We haven't talked about water coming up, which is bedeviling. I'm going to use that word again.
Rising damp.
Rising damp, yeah. Probably we learned that from Bill Rose's book, Water in Buildings. It comes down with gravity, but if you have a continuous column, it can climb quite a bit against gravity and in the liquid form. And so we have to stop water coming down or control water coming down. We have to control water coming up. And, you know, when they were doing masonry buildings that moved from below grade to above grade using brick, there was always something called the damp course. And then they would put a material in at that course, like either a fabric of some sort with, you know, wax or asphalt or a metal, because that was where the rising damp had to stop. And there were a couple of buildings in the complex at Building Green.
Why would you choose to stop it before you hit grade? Why not just let it dry out at grade?
I'm not sure what you mean. I mean, it's coming up through the brick, right?
Yeah. But you said just below grade, they would put in this course.
Oh, no, I'm sorry. But usually about 3 or 4 courses up, that's where they put the damp course.
Okay.
Yeah.
Above grade.
Above grade, sorry. Yeah. Because you can see it on these.
Okay, so it does have the ability to dry out to the outside.
Yes. Yeah. And I'm pretty sure that there was a drip detail as part of that. So it was to be a capillary break above grade. And then the water that was coming down the face of the brick, that was the kick out to have it, you know, drip off rather than run completely down the brick. And I didn't know that until I was looking at the buildings on Bird Street. And I thought, wow, that's kind of a funky design there. Why is there so much efflorescence down low from the mortar and not above? And that's when I think, well, there's a damp course in there. That was a detail.
Let's talk about capillary breaks, because I don't believe in them. So I know, you know, you've talked about them. I just have, and I say this only because in some of the recent videos that we posted and stuff, it's been a hot topic with a lot of people. Why don't you have something over the footing? Why isn't there a membrane over the footing? And my response is always, if I'm getting water to the top of the footing, I didn't do a good job with my water management below the slab, right? So if I can treat it and solve for it there, then why would I ever have a problem of stuff rising up through the footing?
I think you're counting on the fact that if water in liquid form gets to the bottom of your footing, then by capillary action, it can go up through the footing and then continue up the wall above, correct?
Yes, that's what I'm talking about. But I'm talking about, I don't believe that's a problem.
Well, because you've never seen it, right? You're basing this on empirical, not the fact that you don't understand capillary action.
No. I understand. Yes, I understand it. I've never seen it.
Yeah.
Exactly. Yes, it's not that I don't believe people saying that water, but if some water got into the bottom of my foundation wall, what do I care?
Well, I think part of it is that it's sort of you have the opportunity to do it now, and you don't know that for sure liquid water is never going to reach the bottom side of your footing. So, for example, in Brattleboro, our house had no water or damp proofing on the outside because it was built in 1910.
But I'm talking new construction and older stuff. Okay.
Yeah.
But there we don't have the ability to kind of go in there and slide a membrane in anyway, so you're stuck.
So there is a circumstance that I've experienced twice at that property where we had a really cold winter, the frost line dropped way down, and in late March we got a torrential rainstorm. So here's this, 3 or 4 inches of water sitting on top of compact snow, and it's looking for someplace to go. And about a 1/2 inch to 3/4 of an inch channel of thawed soil was right against my foundation. I had a 9-foot column of water, only a 1/2 inch wide, that was driving water through the cold joint and also up through the footing, because I had one circumstance where I had actual hydrostatic pressure on that project. So does my house experience hydrostatic pressure from groundwater? Never. But twice in 22 years, we had a really heavy rainstorm after a really cold winter, and we would get this water column. And the pressure is not a function of the width of the column. It's simply, the height of the column. So it doesn't matter if it's a 1/2 inch or 3 inches, it's still going to exert the same pressure down wherever it can leak in. So, I agree with you. The number of buildings that I can tell you where there was capillary action that led to decay is amazingly small. I more often see extensive efflorescence from unprotected above grade with splashback, and I see tons of efflorescence that's in the top. You go to the outside of the building and there's this much exposed. Then you go to the inside of the building and there's just white dust all over that 8 inches. And so that's capillary action of not down at the footing, it's splashback at the above grade portion. So it's funny, there was an engineer at the research center that told me, he says, I think that capillarity is a bunch of crap because, how often does water travel vertically up from the footing 8 feet to hit the mud sill? And I told him, I said, I don't have an answer to that question. But then when we had these short cycles at the above grade portion, I thought, now it wouldn't matter
but
what
that's
you down.
different than what I'm arguing against. I'm arguing literally at the bottom of the footing, and that costs money, right? I mean, what does it cost to put a membrane? It's probably $3,000-$4,000 at least to put some trowel on stuff across the top of the footing before they put.
Would you do it differently
down?
if you knew there was going to be a finished basement or an unfinished
No, I
basement?
do it. I mean, we do $1 million basements.
And you do $1 million basements with like
no
shuffleboard in the basement. So wood directly on
the huge media room.
I think that's insane. I would bring my full Monty to that, because if you have to look at the client and say, yeah, well, we could have put something there to stop that water. I don't know.
I tend to be with Steve on this one. I've never seen that be the water problem in a basement.
Okay.
And part of it is like,
I would rather say, let's take that $4,000 and let's sign a long-term contract to have a kid come and clean the damn gutters out, because that's going to be why we have water problems in the basement, is because you didn't clean the gutters out and they got plugged.
I totally agree with that.
That's a way bigger risk to me. I think
details below grade, where to solve it, you have to dig up the whole perimeter of the foundation. Why play with that? But
I agree completely. Like, you're going to have it's never going to be cheaper than to do it first time before you cover it up. But
you've heard me say this many times. If I go and look at a soils profile and know that absolutely the groundwater table is 30 feet below the surface, then that, why would you worry about that? But I get clients all the time that are, blasting through ledge or where there's groundwater. You go to the soils, it says right there, there's, potential for groundwater at 36 inches.
But understand, I'm not necessarily saying I don't care about the water. I don't put it in the capillary break, but we'll do extensive outer pipe and inner pipe water management, right? So if I dig a hole and there's standing water, chances are we're probably going to pull it out of the water.
Yeah.
Right.
Okay.
And stuff like that. What I'm saying is the capillary break is like the very last thing on my list, that there's other things you should concentrate, because I think some people think the capillary break is a savior from doing other things that they should be doing. Right. It's like, let me put the capillary break in case water gets up there. If water gets up above my slab height on the outside of the wall, then I didn't put enough money into my sub-slab water management system.
I think you're wise to keep the mantra of, if we can move the water, then we have to do less stopping of the water. I mean, I totally agree with that. Because then you're starving the porous material. Yeah,
exactly.
Yep.
Exactly.
So next time we're going to continue this discussion with the control layer managing air. But it's important to reiterate the fact that if we haven't done this one, it doesn't matter if we move on to air.
Yeah,
If the building's getting wet constantly, that is a much larger problem than all the other control layers.
and I think that we have to design for the worst conditions. Like when you water test the window, it's like horrible conditions. But if your tolerance for water leaking at a window is near zero, then you have to anticipate that it's not just protecting against rain falling down. It's talking about a cork curve of an event with it's all being wind driven. So, you know, there are many things we do in a building where bringing your A game is not required. And I think with water, it's the one that, you know, we all agree it's the one you got to worry about first, because it won't matter for the other control layers if the water management's not continuous.
Okay.
That was fun.
Steve, do you have any closing
Oh,
thoughts?
of course I do.
Yeah.
I wanted to tell you guys about the new electric fence I put around my property. Yes.
Was this for keeping people out or keeping things
A
in?
little bit of both.
Oh.
My neighbor was dead against it.
It's a safe space because probably your neighbors don't listen to these podcasts.
Not anymore, he doesn't.
I don't. My neighbors don't even. Actually, one of them moved. I don't even talk to the new one. They've been in there 2 years. They're like real.
Private.
They beyond
private.
Yeah, I'm sure that it's them.
Maybe they do know who you are.
Goose is a pretty social person, or
That's one way
Goose
to
is a pretty
describe
social dog, and so when they don't, like the neighbor that was there previously, the daughter would like come over and she would pet Goose, and like he thought she was it. He'd jump the fence and play with her in her yard until I had to make the fence taller. I mean, when you think about it, though, it probably went to about 8 feet, but the fence was probably about a little over 5 feet tall. That's commitment. He would go to the other side of the yard and sprint and leap over the fence. And it's like, if you don't make it, buddy, like it's kind of like an airplane taking off, right?
You must really want to get outside the yard.
You must really want to get outside the yard. Yeah. So, anyways.
Stay tuned until next time. We're going to talk about air and why that would be something that we're trying to, hold your breath until
Taking
then.
a deep breath.
Questions at unbuilditpodcast.com if you would like to send in a question. And until next time, have a good day.
See you around.
Bye-bye.